GCSE Maths, finding the equation of a straight line. We have plenty of different methods to do that, but we're going to use the y equals mx plus c method. And pretty much the things I try and remember is if you know the gradient and you know a point on the line, you can find the equation of that line. Now, if you know 2 points on the line, then you can work out the gradient because of the formulas and stuff in the previous videos. Hopefully you remember that. But the crux of it is if you know a point on the line and the gradient, then you can work out the equation of that line. That's pretty much what this is kind of telling you here. And it's y equals mx plus c. Just a reminder then, this is the gradient and this is the y-intercept, as in where it crosses the y-axis. So first one, example 1, this is a bit of an odd example, but let's take a wee look at it anyway. Find the equation of this line. So can we find the gradient? We can find the gradient because we know 2 points on the line. So I'm going to go m equals y2 minus y1 all over x2 minus x1. And what are my two coordinates here? This is the point minus 3, 0. And that's the point in 0, minus 4. Let's call this one number 1 and this one number 2 and just sub in then and see what we end up with. So we're going to have minus 4, take away 0, and then for the x coordinates, x2 is 0, minus 3, and that's going to give us, that's a positive 3 on the bottom, minus minus and a negative 4, so with minus 4 over 3 then is my gradient. So I'm going to sub that into y equals mx plus c, y equals minus 4 over 3x plus c. Now normally what you would do in this situation is if you know a point on the line, for example, say we knew it went through the point minus 6, 12, I'm picking that at random, I don't think it's right, is you would put in minus 6 in here and 12 in here and then work out your c. But in this particular special case, we of course we know the y-intercept, we know it crosses there at minus 4, so we can just sub in a straight minus 4 there. So y equals minus 4 over 3x minus 4. And that's us done then for that one. Example 2, find the equation of a line with gradient 4 which passes through the point minus 1, 5. This is exactly the one I was talking about above where we need to do a wee bit more. So we know y equals mx plus c, and then we know y equals 4x plus c. The point minus 1, 5 lies on this line, so we know it works for this equation. So we substitute in our y and our x coordinates to find our c. So minus 1 is x and 5 is y, so I'm going to exchange my y for 5. 5 equals 4 upon minus 1 plus c. 5 is minus 4 plus c, and that's going to give me, once I add the 4 to both sides, c then is 9. Therefore the equation of the line is y equals 4x plus 9. Find the equation of the line which passes through the point 5, 8 and minus 2, 5. As I said at the start of the video, if we can know the gradient and a point on the line, we can find the equation of the line. We know 2 points on the line, so we're good with that. Can we find the gradient? Yes, of course we can. We can use our formula. So m equals y2 minus y1 all over x2 minus x1. That's 1 and that's 2. We'll call it, doesn't matter of course, but with 5 take away 8 and then minus 2 take away 5. Some awkward numbers here, but that's going to be okay. 5 minus 8 is minus 3, minus 2 minus 5 is minus 7. What a horrible gradient. So our gradient then is going to be 3/7 because the two minuses will cancel each other out. That gives us then y equals mx plus c, y equals 3/7 x plus c. I'm torn between which ones here to use, but let's take a look. We'll sub in the second one. You can either now substitute in 5 and 8 or minus 2 and 5. I like this because there's no negatives, but these numbers are slightly smaller, so we're going to go with this. So 5, which is our y coordinate, is equal to 3/7 upon minus 2 plus c. 5 equals minus 2 times this is just going to give me minus 6/7 plus c. We need to add 6/7 to both sides, so we get 5 and 6/7. So my final equation of this line is y equals 3/7 x plus 5 and 6/7.